So I will share my screen. All right, so ACCONEER, we are a company based in Sweden. So we've been around for a while, and we released our first product, the A111, in 2017. Already from beginning, we distributed this on a global scale, and we have global distribution and customers in Europe, US, Asia, etc. And here in Europe, we're working very close with CODICO. We have last year we reached a milestone of shipping more than 1 million of our A111 radar sensor, and we can also now say that we are a trusted supplier within automotive, and there will be cars rolling out during this year. So of course we're working in many different industries, but being in automotive is also a good quality stamp, and it also shows that we will be in the market for a long time. Financially, we are listed on Nasdaq First North, publicly listed. As all financial information is available on our investor page, and this is public information. So, as I mentioned, we are working on many different markets. So we have a pretty broad scale of customers, and we have a good customer base within all these four main segments: consumer electronics, IoT, industrial, and automotive. So we will talk more about the use cases here, but at the moment we see most of the products within Internet of Things. One of the reasons is, of course, that it's a very good fit with the sensor: small size, low power consumption, robust detection outdoor, etc. But also it's a bit shorter lead time to get out there in IoT market. And use cases like detecting vehicles, parking sensors, level sensing in tanks, waste bins, etc., human presence detection. Within consumer electronics, it's a lot about human interaction, also people presence detection, but also the fact that you can see the intent of the user. So you can see if you are getting closer to a device, approaching a device, and then you can wake up. The sensor can also be used for gesture control, touch this button, etc. When it comes to industrial, agriculture, and automotive, these will probably be the biggest segments from a volume perspective going forward. And right now we are within industrial agriculture. It's about manufacturing, for example, to detect parts during manufacturing in conveyor belts. And agriculture, there are many different use cases like farming machines and also tank level, of course. Automotive, here it's a lot about in-cabin detection and detecting people inside the cabin, but also short-range use cases outside the car, like opening the trunk lid, making sure the doors don't hit into objects, etc. So we're not a car radar in the sense to detect other cars. There you need to use the 70 gigahertz band. But 60 gigahertz band can be used inside and for user-related use cases for the car. So as Johannes mentioned, we just released our new radar chip called A121. And it's the same, it's an upgrade of the previous A111, so it's the same concept. And we're using our unique technology called pulse coherent radar technology. And with that technology, we are sending out short picosecond pulses. Between the pulses, we are shutting down the sender and the receiver. And by that, we can have leading power efficiency, very low power consumption. We also have designed this to be very small, and it's a complete radar system into one package. So you don't see it here, but it's about 5 times 5 millimeter, 0.8 millimeter high VGA package. And you see the two light parts on the substrate on the picture. These are the antennas. So the antennas are integrated into the substrate. So it's a complete radar system with antennas, analog part and digital part. So this is the smallest footprint we have seen in the market. Also, we have, since this is a coherent solution, it is also very, very accurate. And we can measure the absolute distance to object with millimeter precision, but also looking into the phase domain of sending out and receiving pulses, we can go down to around 20 micrometer for relative movements. And then as well, since this is a radar, it's also very robust detection. So there's no natural sources of interference. It works in different light conditions, indoor, outdoor, for different kind of colors on the objects, different sound. Well, if you have sounds, etc., it also works. Many customers are using it in pretty harsh environments like dust and dirt, for example, outside the car under the trunk lid. Farming machines where you have a lot of dust, of course, and then the radar is a very good choice. You might be familiar with the 111. So as I mentioned, the 1-to-1 is an upgraded version, and if you've been using the 111, you will see that the 1-to-1 has better signal to noise ratio. So we have been able to decrease the noise floor to get a better signal. And in the end, that will mean that you will have a longer range to work with. And basically for static objects, you will be able to double the range. And we have now set the maximum to 20 meter. So depending on the use case and what kind of objects you have, you can go up to 20 meter. We also done improvements when it comes to power efficiency, and as an example, if you're running presence detection, you can expect up to half the power consumption. And also one of the main reason here to do this new product was to increase the operating temperature. So we can now comply to automotive standard up to 105 degrees operating temperature. So it's -40 plus 105. The previous 111 went up to 85 degrees. So that's important for our automotive, but it could also be important for other, for example, industrial applications. And then we've done some improvements also for the integration part. So if you're running a MCU, host MCU with 3.3 voltage, you can now connect that directly with 3.3 voltage interface to the sensor and get rid of some components and make the integration easier. And just what we have done for 111, we're working a lot with reference code to make it easy and also to help you to realize your use case. And already now with the release of the 1-to-1, we have reference applications for smart presence. We will show a demo later on here. Also tank level to measure the level in tanks. That is also using our distance detector, which is a high-level API for measuring distance to objects. We put quite a lot of work into the distance detector to make it easy to use. It's configured, and it sets kind of the optimal radar parameters depending on the conditions you have. We also see that the 1-to-1 will open up for a lot of new, interesting, advanced applications. And the things we've been working with so far is surface velocity measurement. We will show a demo here. Traffic flow, also related to velocity, seeing the speed of pedestrians and bikes, etc. And the third one here that we will also show a demo of is vibration measurements, where you can see how machine and different parts are vibrating. really utilizing the sensitivity of the solution. Yeah, a short recap of the roadmap we have. 111 was released in 2018. We now have the one-to-one, basically an improvement. It's pin-to-pin compatible from a hardware perspective with the 111. So if you already have a design with 111, it should be easy to replace with the one-to-one. With all the improvements we've done in software, it's a completely new API, so you need to kind of rework the application. But there we also have a lot of reference code to make that easier. Going forward, we have interesting stuff going on as well. We have the A2 next generation sensors, still of course using the pulse coherent radar technology, but here we are bringing in multi-antenna solutions with several senders and receivers, and by that we will be able to get angle resolution. We will also move in some data processing into the chip itself. With the multi-antenna, beside angle resolution, you will also see further increase of range. And the A2 will be taped out during this year, and then next year we will have the release of the A2. Still, the one-to-one will and the 111 will live for a long time, so we see still a need for really small, cost-efficient solutions with high precision, of course. We were actually the second one in the world to release a commercial radar for the 60 gigahertz domain. We now see a huge interest in this area because you can build very accurate, precise solutions with small size. Larger companies are moving in, like TIA, Infineon, etc. All our competitors here, when it comes to radars, are providing continuous wave frequency modulated radars. So per definition, they are sending all the time, and ACCONEER is the only one providing pulsed coherent solutions. So that means that we can always have lower power consumption. And then we also made design choices to make it very small, and with a small size, you also get cost-efficient solutions. So this is how we position ourselves: low power consumption, small size, high precision, and cost-efficient. Okay, so let's go in a little bit into the kind of technical overview. The one-to-one has the same radiation pattern as the 111, if you're familiar with that. So it's a pretty wide field of view. This is the half power beamwidth, where you have most of the energy radiating from the radar. And you can see it's 80 degrees in one direction and 40 in the other. Yeah, within this cone is typically where you will have the field of view. You will have some detection outside this as well, especially if you get close to the sensor. But typically, this is the field of view. And in many use cases, this is good to have a wide field of view, like in people presence detection. In some use cases, you would like to narrow this down, and you can do that by physical integration, putting lens on the electric lens with a piece of plastic to narrow down. And we have example lenses going down to 10 degrees. The sensor needs to be integrated into the system, and it's pretty easy integration. SPI interface for raw data to host MCU. We provide radar software, so you can build your detection algorithm on top of our radar software. So we have an SDK with APIs, power supply, and the clock reference. So either you integrate this, or we also have ready modules with host MCU. From software perspective, we have an SDK. We have a low-level API, the raw data. We call that sparse IQ, and we have high-level detectors for certain use cases: presence, distance, obstacle for robotics. And on top of that, we also have some reference code and reference applications. So we put quite a lot of effort into making it easy to integrate. We have a module down to the left here, XM125, includes a Cortex M4 from ST and one sensor A121. We also have that module mounted on the breakout card. We call it XE125, and that is our evaluation kit where you can either flash the module or you can actually connect this breakout card to your PC through USB, and you can run Python tool for real-time data to evaluate your use case. Then we have the software. All software is available on our developer page. Reference code, SDK ported to different cores. And if you have an MCU that is not listed on our developer page, you can reach out to us and we will make sure that you can get the port to that. Okay, so going into use cases, and we will do this within our main segments. So starting with consumer devices. And as I mentioned, for consumer devices, it's a lot about presence, but also we include robotics and object detection, etc. in this segment. So here are some of the customer references we have. We have up to the left, you see keyboard using presence detection. So when you get close to the keyboard, it detects that you are there. So that means that if you move away from your workstation, you can shut down the station and save power, and it's also a kind of a safety feature. We have Orbital here doing a shower with recycling water, and using our sensor to detect if you are there or not. So it's also presence detection, light up the display, and also related to other functions in the shower to see if people are present or not. Robotics on the bottom here, we have Zucchetti with a 20 ZR using radars to detect obstacles in front of the robot, but also detecting the ground. So they have one sensor pointing down, and with machine learning, they can see if the robot is running on grass or not grass. So making sure that the robot remains in your garden. We have the Poik robot here as well from Sony, using it for obstacle detection. All right, going into some demo stuff here. So Martin has prepared a presence detection demo.
Yeah. Okay, I hope you see the screen now. I'm sharing the exploration tool that Magnus previously mentioned. It's a free tool that we provide. It has all the high-level detectors that you can try out. So I've just connected my PC to the evaluation kit here, and I get the data streamed into the tool. So for this demo, I've chosen the presence detector. So I would just like to show you the sensitivity of the A121. So you have three windows here showing data coming out. So the upper left shows motions, and specifically fast motions. So now, since I'm sitting still, that is rather low, close to the threshold. But on the right side, you have upper right, you have then slow motions, and that is typically human breathing and also heartbeat. So this is what we, for example, use in automotive when we're detecting small babies, etc. And at the bottom, you have the presence score. So you can also see at what distance the presence is detected. So I'm sitting now a bit less than 1 meter from the radar sensor, and you can see that it's the distance is presented there. So just to show you now the difference between fast and slow motions, if you look up to the left, you can see if I start moving now a bit more drastically, you can see that you get a higher amplitude on the fast motions. So basically this means that you can filter out not only motion, but also the type of motion that you would like to detect. Are you interested in fast motions or in slow motions, or maybe both? And you can move a bit away from the sensor here, and you see that in the bottom graph you get a longer distance. So with the A1-to-1, we have made a huge improvement in data quality and therefore also extended the range that we can measure. So we can detect people sitting completely still at 7 meters. And yes, I think that's the presence detection.
Super, thank you very much, Martin.
Yeah.
Go back to the presentation. So as Martin mentioned there, we have improved the range. So this is just one of the first tests we did with the 1-to-1 presence detection, where we have the sensor mounted on a wall. And then the green part here, we actually have person standing absolutely still in different positions. And in the green fields here, we have good detection. So that means that we can actually detect very small motions up to here is 6.5 meters. We can easily go up to 7 meters, but also it's a pretty wide field of view. So it's a 6-meter room here. So that means that we cover basically a mid-sized meeting room with just one sensor on the wall. Going further here into IoT, smart cities, which is a huge area for us, and there are a lot of different applications. So these slides show examples of use cases that our customers are working on, and where we have a green mark here is where we have they also release products that are available in the market. So within traffic, short range pedestrian flow, detecting people walking, but also the speed of people, and you can also count people, of course. Crosswalks, touchless buttons for entering the street, and here you can also combine the touchless button with presence detection. So if people press, you can then scan an area, maybe up to 3-4 meters, to see if the person is still waiting to enter the street, or if he's walking away. You can then go back and don't stop the traffic, right? Toll gate, this is basically open up gates for detecting cars. Vehicle speed detection, so putting the sensor close to the street and detect the speed of cars passing by. Smart buildings, also touch this button to open entrance, way to entrance and exit. Sanitary bathrooms, there we have customers working with presence detection in bathrooms, but also when you are entering the toilet to have automatic flashing and so on. Presence detection with the sensor placed in lamps. Then you have the sensor in the ceiling, and you can scan an area around 4x4 meters outside under the lamp. Further in smart buildings, access control. We have customers waking up camera, for example. When you get close, you turn on the camera. Presence in smaller rooms like ATM, rooms for ATM machines. People counting when you enter and exit entrance. Infrastructure, structural integrity, to make sure that things are in place. It could be train track, or it could be other kind of buildings, bridges, for example, to make sure that they are in place. So you basically have set the radar as a known reference, and then you're detecting the distance to a part of the structure. And then you can see very small movements down to millimeter. Level measurements in different kind of tanks, waste bins, wide range of different waste you can see with the radar. Sewer systems, this is a huge area to detect the level. We'll also later show also the surface velocity of water. Parking, detecting vehicles in parking lots, also related to EV charging, where you would like to see if there are cars parked that are not using the charging station and not charging. So here are some of the references. Enea in Norway, using the radar for vehicle detection on EV charging station. IoT solution, providing parking solutions and parking sensors. Here we have a huge customer base, more than 30 customers. Most of them are doing ground-based sensors for outdoor usage, but it could also be on the roadside, mounted on the pole to detect cars. Iprotoxy, general purpose level sensing for IoT. Metasphere, using the sensor for sewer system and levels, and battery-driven devices you put in a sewer system to get the big data and how the levels are changing in the whole system, and then you can see how if you have any issues and congestion and so on in the sewer system. Yeah, and then we'll show the latest related demo here with the surface velocity. We'll turn on the camera here as well.
So again, using the exploration tool to demonstrate one of our new use cases, which is surface velocity. So with the A1-to-1, with a higher data quality, we are able to do these kind of very fine measurements. So what's actually happened here is that we have built a little prototype here, which basically streams water down this half pipe that you see, and we have the sensor is sitting up here, looking down at the stream at the roughly 45-degree angle. And so what the radar sensor actually sees here is the small ripples on the surface that it can detect and estimate the velocity of. And so I'm using now the surface velocity application in the exploration tool, and basically you will, in the graph at the bottom here, you will find the velocity reading, which is in this case roughly 1 meter per second. So this actually works very well, and we can measure much faster velocities than this one. It can, for example, be used to measure extreme high pressure water jets to get the speeds up to 30-40 meters per second. But I think for sewer system applications, etc., this is quite interesting to get both the level of the surface and the velocity to get a good picture of the situation here. Yeah.
The sharing, so you see the pipe. If you stop sharing, it
okay,
be bigger.
Okay. Yes, this is now you can hopefully see a better picture of my display here. So my setup. So I have the sensor sitting up here, and the water is streaming through this improvised half pipe at roughly 1 meter per second. So you can be around 1 meter from the surface, maybe more, to read this velocity accurately. And
Perfect.
I think that's it.
Great. So yes, we have big interest for this application, especially people now using the radar for sewer system and then combining the level and also the surface flow. You can understand more about how the water is flowing through the whole system. Going into industrial and agriculture. So here is a big number of different use cases and new things are coming up on regular basis. So here are some of the customer cases we have. Inventory control and basically using the radar as a proximity sensor to see if one of these cars is loaded with cargo or not. The example here is at an airport where you can see this basically place the radar on this called car or the wagon, right? Yeah, to see if it's loaded. We have livestock management and one example is here a customer using the radars at a gate where the cows are entering, and by having multiple radars you can actually measure the whole girth of the cow to see the size. We also have NFC tag on the cow to identify individuals and combining that with the girth measurement and weight, you can see how the whole livestock is growing and sort out individuals, etc. Another interesting thing that is coming up here as well is hydraulic systems and basically using the radar to measure the distance and how far the cylinder is extended or compressed. And you can of course use the radar outside the structure to measure this. But we have customers that managed to put the radar inside the cylinder, shooting through the fluid and detect how compressed the cylinder is. And this is a huge benefit for the whole market, because then you can have smarter machines, you can have more control of the management of the hydraulic system. Cargo load, also a little bit related to inventory control here. So with the radar in standard containers, for example, you can see if the container is loaded. You can also understand how much load you have in a container to basically manage your whole fleet of containers. Beside this, we're also looking into vibration measurements that we think is very interesting application going forward. And we will show that one now. Yeah.
Share my screen.
Okay.
We can see both video and exploration tools. So now I have chosen a vibration measurement application in the exploration tool, and what I have here is just a regular tuning fork that vibrates at a certain frequency, and this is something that has been enabled by the A1-to-1 and the accuracy and the possibility to detect really small movements. So as you know, you can hear the sound, you cannot see the vibration with your own eye, but the radar has the possibility to see these small changes in the phase due to the vibration. So I will show you a quick demo here. So I will pause the screen, and as you can see, we got the detected frequency at 598 hertz. And this is something that can be used for condition monitoring, for example, of different machines and vibrations in industrial applications. And of course, the benefit here is to be able to do it touchless So you can look from a distance at something that is vibrating and understand the condition of the machine.
Yeah, and you can of course pick up multiple frequencies here as well. So
yeah, I can try a different frequency here. This is a tuning fork with a slightly lower frequency, so 295 hertz. And as Magnus mentioned, we can also see if it works, detect multiple frequencies at the same structures.
And I mean today there are a lot of vibration sensors you put on the machine, on the device to measure the vibrations, but what we can do here is to do it remotely, maybe half a meter or so from the machine. And it could be, for example, that machine is very, very hot environment, so you cannot put it on top there. So we think this is a very interesting application.
Yeah, and we can measure frequencies up to around 20 kilohertz. So we can measure very high frequencies.
Right, so the last segment here is automotive, and here we are very pleased to show that we are now integrated into cars, and we have the world first cars with the interior radar system coming up. We have the Volvo EX90 and Polestar 3. And in those cars, they are using our sensor inside the cabin. Main use case is to detect presence, to make sure you don't forget your child or pets in the car when you're leaving the car. So here they utilize the benefit of radar to detect very small micro motions. So even if you have a kid sleeping under a blanket, you will be able to see it with the radar. And then, of course, since we have the radar then in the car, it's also used for detecting where people are sitting, for seatbelt warning, and also anti-theft system for alarm systems. In those cars, you're also using the radar outside to detect the foot, so gesture control to open a trunk lid. That's a good example of an application where the radar is used in a very harsh environment under the car. So you have a lot of dirt and dust there, of course, but then still it can work very reliable and very robust. Okay, we're coming to the end of the presentation, so I hope you got some ideas and get some information about our solution. Validation kits are available at CODICO, and they can support you to get started. We have a developer page, ACCONEER.com, where we have all information, data sheets, user guides, all software for the validation kit and for the host MCU is available on the developer page. So it's easy to download. And you should be able to, in just 10 to 20 minutes, be able to set up the EVK, connect to your PC, run the stuff that Martin was showing here today. In the validation kit, you can set all the radar parameters that you then will have in the embedded code when you go into embedded development. And on a regular basis, we are putting up a new interesting example algorithm in the Python tool as well, like the velocity management, measurement, etc. So make sure to update the Python tool on a regular basis, and you will see new interesting stuff coming up there as well. All right, thank you very much. So maybe Anna, you have some questions that you see there.
Yes, we have some questions in the chat here, and feel free to add more. We will answer a few of them now and then send out an email later with more replies. So the first question here is, can you expand a bit on the distance range that can be detected and the max distance for different modes of operations and parameters that may affect the maximum detected distance?
Yeah, I think so. This is presence detection, I assume, and without using a lens is something that narrows down the beam and makes it stronger, the signal stronger, adds gain. Without using that one, we have achieved a 7-meter distance roughly for people sitting very still. I mean, with a lens narrowing down the beam, you can extend that several meters, I would assume. And also, if you have movements that are maybe bigger and faster than just someone sitting reading, we can also probably extend the distance slightly. I see also, am I able to recognize and evaluate direction of the movement? So we can detect if the person is moving towards the sensor or if he or she is moving away from the sensor. So you can get the direction for example, if you have a screen that you would like to wake up, you can see if a person is moving towards the screen, you can light it up. And when the person is leaving the screen, you can turn it off. And if you're passing by sideways, we can ignore that motion, for example.
Great. We also have a few questions about water flow and one question is, does it work on only water or other liquids as well? And I think specifically sewage water.
Yeah, definitely. So everything that is moving, it can also be, for example, a grain or something like that. But definitely all liquids, but also particles, small particles that are moving. Some sense. So yes.
Great. Can water flow be detected inside a plastic pipe?
Yeah, it's a very good question. I've received a question before, and so basically, what the radar sees is the ripples on the surface that is created when you have something flowing. So if the pipe is full of water, there will be no ripples. So then it will be difficult to see the velocity. But if it's like the setup I showed you just recently here, a pipe where water is when water is flowing and the pipe is not completely full, then the radar looks through the plastic because plastic is transparent to the radar, and then it will see the ripples and you can get the velocity. So it depends on how much water that's in the pipes.
There was a question which materials are transparent for the radar, and the 60 gigahertz bounce on most of the things that you have around you. 100% of water and more or less 100% of metal. But materials like plastic and wood is semi-transparent. So some of them you will go through, but you also will get the bounce on plastic. Then texture like clothes, etc., is transparent.
Yeah. And there's a question here related to presence, and are those radars safe? What if I want to use it as a baby monitor?
Yeah, it's also a good question. So it's perfectly safe. We usually say that, as an example, our radar emits less than 1% of the effect compared to a mobile phone. So it's very safe.
And it also bounces 100% on the skin, so nothing will get penetrated. And of course, we comply to all the safety standards like FCC, EN in Europe, etc.
And here's a question about power consumption. What is the lowest possible power consumption with a sampling frequency around 1 Hertz?
Do you know it by heart, Magnus?
That's a tricky.
I think we have data sheets on that. So to give you a precise answer, I think that's one of the questions we can answer.
We probably need to come back on that.
Yeah, we can answer it already.
So something about measuring the speed of a car, so up to 100 kilometers per hour. Yes, that's possible. I think we can measure at least up to 200 kilometers per. So
Yeah.
Mm.
So normal traffic
Normal
with
driving.
cars is no problem.
Yeah.
If you're into Formula One or something.
yeah,
Cool. If the radar is watching at the ripples of water, is it looking at the wave velocity or the
it's
actual water
yeah, it's
velocity?
the water velocity. Sure, how I can explain that in a physical stuff happening there, but yeah, it's the water velocity, and we have of course compared our measurements to the real values, and we see a very good correlation between the real velocity and what we measure. So yes, it's the water velocity.
Yeah. I don't know how much time we have, Johannes, but maybe we can take a couple of more questions. It's great to see so many questions coming in.
We comply to red.
Yes. Yes, please
Good.
continue
Yeah.
for 5 minutes or so.
Okay, great. Thank you. So here's one about people counting. If you want to use this module to count people entering a hotel room, what are the cons? What happens if a kid enters at the same time with his parent? Can we differentiate 100% for sure how many people enters the room?
Yeah, we have tested this quite a lot, so you can get pretty close entering the room if you kind of one after the other, so you can be pretty close. Of course, if you go in parallel, you will have a problem. But it's very accurate for that. You need to work with two sensors in order to get direction in and out from the room.
Yeah. And another question related to hotel rooms is if it's placed in the ceiling, can it detect the breathing of a sleeping person? And what happens if this person perhaps covers his head with a blanket?
Yeah. So with a one-to-one, we can cover, if you have it mounted in the ceiling, you can cover an area of roughly 4 by 4 meters. And you can detect, yes, breathing. So person lying perfectly still and only breathing will be detected, and a blanket on top of the person will not change anything, because that is completely transparent to the radar. And the radar signal will bounce on the skin.
Yeah. We also got a question about where the sensors are produced. Europe, Asia, US.
The wafers are produced in Singapore, in Asia, and then the assembly is done in Korea, and then the testing of the chips are done in Europe.
Cool. Here's another question. If it's possible to distinguish the size of the detected object or the radar cross-section.
Yeah, it's a bit more tricky. Of course, you will have a stronger signal coming back if the object is larger and have a larger radar cross-section. But it's slightly difficult to get very accurate reading on how large an object is. So it depends a little bit on what type of application you are referring to.
You can probably get kind of an estimate, but if you want to have a more accurate answer, the next product A2 will be more suitable.
Yes. And another question about certification. So what do you have to do as a customer to concerning certification? For example, red.
Yeah, we comply to FCC in the US, and it depends a little bit where in the world. But when it comes to Europe, we comply to European regulations, and you can basically reuse the test that we have done, but you have to do the certification yourself. Basically, go to notified body and with our test results and get the certification. In US, you can reuse our modular approval. So you basically take our FCC ID and put that on your product.
Great.
There's a question about water vapor and high humidity. So we can handle droplets on the cover on the radar, in front of the radar. As long as it's not completely covered by water, we normally works fine. And high humidity is also rather fine. It can reduce signals slightly, but not to a large extent. So as long as it's not fully covered by water, we can detect motion, etc.
Great. How does the radar compare to IR for presence detection when it comes to cost and power and so on?
Yeah, minus usually.
Of course. I mean, with the radar sensor, you get much more robust detection in different conditions. So I think that's one of the advantage. The other one is that you can detect the very small, tiny motions. So even if you're standing still, you get detection with the radar. So you get true presence detection in sense. The IR might be slightly cheaper. So even if we are very cost efficient when it comes to radar, it's a small price premium, but by that you get more robust detection, and you can see true presence when people are still. You also get some further information with the distance to people with the radar, so you can do some more advanced detection on top of the normal presence detection.
Yeah, there's a question about our SDK, and we deliver our detectors in binary form. So yes, that's currently the status, and in Python you also have, as you know, the detectors implemented, and there they are available in source if you want to dig deep into that. But I understand your question. It's about the C libraries, and currently there's not a plan to release the source for these, but it's not. It can be changed. But if you have a specific question on this, feel free to file a ticket in our ticket system. I'll try to help you with your challenges you see.
Yes. So should we maybe do last question, and then we will answer everything over email also?
Right.
Yes, please.
Yeah, I had a question about typical MOQ here for our application, and I mean the whole. We love all customers, like small customers and big customers, and we also have a support setup and open approach in order to support also customers with lower volumes. It could be, of course, a lot of interesting applications there as well, and we also have possibility to ramp up high volumes. So the whole setup here is to be able to accommodate the complete market.
Yes, this maybe was only on one slide. ACCONEER also offers everything together with a microcontroller on modules, especially the A111. And also there's one module available for the A121 already. So this covers and normal pack unit on a tray is 490 pieces, but even that we can ship lower quantities if needed. And standard reel size, I think, is 3,000 if I want tape and reel.
Correct.
So may close now. So thank you very much to everyone, to the participants, to the ACCONEER team. As mentioned, probably next week we'll send out all the material to you, and also recording maybe a few weeks afterwards. Yeah. Any words from the ACCONEER team side?
Thank you
For the
very much
closing.
for spending.
Thank you, everyone.
Thank you.
Thank you.
Thank you. See you next
Thank
time.
you.